It's a really solid list. So be sure to spend some time tonight reviewing that.
Yeah, I started marking a bunch of these, and then I made it about halfway through, and at least reading the headings and going through, because everything you read, I go highlight and then kind of read that section.
Are you putting them in your index anyway, or how you getting them marked in
Uh,
your book or finding them again?
Highlighting in color, like certain colors.
Mm-hmm.
Uh, I have like 6 colors as far as like my calculations and stuff. I've been doing certain things, and then writing notes to see notes, uh, and then important pages like marking the bindings. But most of the stuff I just remember where I put it, like my notes and everything else. Like,
I'm gonna see if I can find this. I'm gonna get my phone to come back on. I think my phone just died. I have a handwritten list of some other ones that were probably about 25 or 30 of them on another piece of paper that a guy that came to my Austin class, which was 2 weeks before the Dallas class. And they're pretty common set of questions that have been on a lot of tests. So you'll probably run across those as well. So I'll send those to you by text here when my phone comes back on in a minute.
okay.
Between that and that list that you got right there, you should be pretty solid. I mean, if nothing else, you ought to be able to knock out 40 questions with them. There's nothing, and then that's enough block of material to kind of get you, rolling on and give you some time to breathe somewhat.
Okay.
Now, when I was talking about that run through and kind of how you take the test, I was dead serious about that what I was saying. And so I don't. Did you feel like you got a pretty good idea what I meant by kind of the run through and all that stuff?
And marking and then going back through. I actually did that last time, and I don't remember where I read that online. It was through one of the when I was going to take and looking up all the classes. It was like one of the suggestions as far as marking them.
It's like on a YouTube video.
Maybe
It might have been mine.
video before.
Okay.
Um,
Yeah.
I went and marked them and everything else. I went back. I did my test, and I'm not like bragging or anything because I didn't pass, but I finished with a 68 and with like 180 minutes left, but I didn't look up anything. That was just off the top of my head. I got an emergency call right before I walked in the door, and I kind of blew my test off, and I just wanted to see what I could do. So did all right. I just did not know any of the calculations. That's the main reason why I kind of blew it off so I could go to work too, is because my first for calculations, I felt like, and it was just.
I lost you on that last part.
It just frustrated me. A lot of it just frustrated me because I wasn't understanding the questions, how they were asking them. Just the stuff in puzzles, like everything's kind of confusing, like giving you extra information you don't need.
Yeah.
Not exactly clear on what they want. Well, to me, it wasn't exactly clear on what they're looking for as far as what the answer, what they were looking for. Like, instead of asking, I can't say it. I don't know how to say an example. Let me look at one of yours and.
Yeah. Like sometimes when they're leading off a question, there's two things I've noticed kind of that are kind of high up on the repetitive scale with them and the way they write these questions. One is that they'll write the question with kind of a leaning toward, like for example, let's say that you had a list of items that you could or couldn't do in a particular install. There's a receptacle in a residential pool rule. Let me find that real quick. It's under 680 dot. I want to say like 23, but it's really kind of toward the front. I need to pull it. Actually, I'll give you a better example than that on the master test. Let me finish this one while I've got it up here. So it was on the receptacle that was being used for a circulation or sanitation system, and it's on page 608 in 680.22A2.
All right.
Now, prior to the 2014, the 2011, going back, there was actually 4 items listed there, but you'll notice this is real common. Did you find it 608 on the right-hand column?
Yeah.
Okay, so it's kind of toward the very top. It's at number 2, circulation sanitation system location. So the rule is that you have to have at least 10 feet of separation from the inside edge of the wall of the pool. But if you meet every one of that list that's listed down at the bottom, in this case, there's only 3 now, it used to be 4, but you can reduce that to 6 feet. And it's not an exception. It's just a code direction that you can have a 6-foot maximum separation or minimum separation if you have those 3 things. So it was a locking type that in the last edition that they didn't that was on there. But what they would do is they would give you the question, ask you about a receptacle that's intent was to serve the sanitation or circulation equipment, and they would tell you that it was a single receptacle that was GFCI protected, and then that it was of a locking type back then was one of the requirements. But they wouldn't give you, for example, of the grounding type part, which to me, a GFCI has to be grounded because you don't have a mechanism without a ground for the device to be able to break open. So, if you ever tried to put a GFCI tester on one of those receptacles in an old house where you pulled out a two prong plug and put in a GFCI, and
Yeah.
you can't test them. They won't open the circuit when you put a tester in there. And it's GFCI protected technically, but the ground part is just kind of integral to the whole nature of GFCI.
Yeah.
And so you just kind of don't even think about that being an issue. But this is one of those sections where you have to have every one of the following. And so if they omit one of those things, it's a real subtle thing to miss. What I was really meant to give you as a better example is one that you probably will have on your test for sure, and that's going to be under 240.4D, the small conductor rule, on page 95.
Yeah.
All right, so I've seen both the 18 gauge and the 16 gauge listed as test questions. Most commonly, it's the 16 gauge that they give you. And what it is that the questions are kind of written around is that they're giving you a conductor that's sized as a 16 gauge. And they're giving you that you're feeding a load that is continuous duty that's a 8 amp value. So you got 8 amps of continuous duty load on it. And then one of the types of questions also gives you the fact that you've got a class T fuse protecting that 16 gauge wire. So if you look on page 95 on the right hand column under the 240.4D, there, you'll notice this again. This is one of those sections that says it has to have all of the following. In other words, you have to have both one and you have to have one of the options listed in section 2 that goes with it. And so the answer to that question would be 10 amps would be permissible for a 16 gauge wire. But then I saw a question about a month or so later that was the exact same question. In fact, I had it on my Colorado Masters license, same exact question, but it didn't give me that it was protected by a Class T fuse. All it gave me was the 8 amps of continuous duty loads. That's it. And so it's a setup to where you read the section and you say, okay, well, you got a 10 amp permission here on 16 gauge wire. As long as I don't exceed that 8 amps, I'm good. And we just kind of assume that we're going to have a branch circuit protection on it. I mean, it's just kind of a given. I mean, how many times do you run branch circuit wire that's a 16 gauge, you don't have some sort of overcome protection somewhere upstream? That has never happened, right? But it's specifically got to be one of these that's marked for use, or it's got to be listed marked for use for 16 gauge copper wire. It's got to be, that's almost the exact same. Oh, it's breakers in the A and fuses in B, and then the special types of like the barrel fuses or whatever, the Class C, Class J, Class D fuses down the bottom listed. If they didn't give you one of those things though, then you can't technically even use a 16 gauge wire, no matter what size fuse you put on.
Yeah.
Because it didn't meet all of the following. So it's a kind of a subtle omission of stuff that makes a required code section be okay to use, if that makes any sense. And the only way to know that is to look every single one of them up, know where they're at, and just make sure that sometimes it's either of the following in some of these code sections. A lot of times it's all of the following, or sometimes they say, one of the following. So it's, there's a lot of different words that boil down to either you got to have everything that's in the list that follows, or you can just pick your choice of one of the things that's in the list that follows. But that it prevents you from being able to kind of guess at those kind of questions, because you can't. I mean, unless you look it up or know it by heart, it's kind of hard to know what the wording is and whether or not you got to have everything, and if they're missing anything in the test question. So that's one thing that they do that I think is kind of easy to write a test question that does stuff like that to you. But The other thing, because it proves that you're finding it in the code book and not just taking a wild guess, I guess, if that makes any sense. But
Yeah.
you got to pay real close attention to the wording of the question. But the other thing that they do is they'll start a question where, we have a tendency to kind of make our mind up of what the question's about in the first 4 or 5 words. And so there was a question for a long time that was asking you for uh, which of the following was considered to be a conductor outside of the building. And then so the way it was worded, let me see if I can do this justice. I think I had it in the textbook too. You see if you on that trap distractor question page, did you go through those 5 or 6 questions over there?
Yes.
I think it's the last one on that section, if I'm not mistaken.
The trick question thing.
Yeah, it's like trap or distractor question is what I think it says. Let's see if I can pull up a copy here.
I was just reading it just when I was waiting for you when you were on the phone. Yeah, here you go.
Is the last one talking about conductors outside or beneath a building, being outside the building?
Oh, it's about the commercial kitchen. Wait, and then there's one about a restaurant.
Now, those are the table questions. So it's after the table one. So it's let me see here.
Oh, the trap one. Yeah, the copper conductor one, or the temporary construction site.
Now the temporary construction size one for sure, but it is. Let's see here. I'm trying to find it on my copy of that. It should be one talking about the conductor considered outside the building. No. See anything like that?
Oh yeah, outside the building right here. A copper conductor shall be considered outside a building's envelope, where a conductor is run beneath the building and shall be considered as not being outside the building.
Yeah. So you read the first part of that question, and it's talking about a conductor. Which one of those is a conductor considered outside of a building? And the article that answers it is also written as okay, everything in this list is stuff that's considered outside the building. It's not a list of things that aren't outside the building because everything's considered to be inside the building if it's not on that list of things that are outside the building. But when you read that question, the first thing in the whole bit of it is that they're talking about conductors that are outside of a building, right?
Yeah.
But then that one word "not" at the very kind of tail end of that test question reverses it's a 180-degree flip going the reverse direction all of a sudden. And if you're reading it quickly, like most guys do because you're in a hurry, you've already made up your mind that that question's asking which one of the following is considered outside the building.
Yeah, I probably would have already flipped to that section.
Yeah, so 240.6 is where it's at. We're not too far away from where I'm actually the next. 230 point. I said 6, maybe 4 actually. 230.4. Is that me?
You just let me.
Means. Point 6 it is. Yeah, on page 84 at the bottom corner there. And in fact, they even word the first option almost identically, where they're giving you 2 inches of concrete, I think, underneath the building. And so that matches up exactly what you're looking for. The other 2 also match up, but they're not word for word examples. So, like for example, the depth under section 230.6, number 4, where it's got an 18-inch of earth clearance, or it's got to have at least that much depth of earth between it and the building pad. If they give you 20 inches of depth, then that's also outside the building, but it doesn't match up visually with what you're looking for. And since the first one matches up with what you're kind of expecting it to be, which is one of the following is considered, you didn't bother with the last one, which was really the one that would be. I think the last one is the answer. Let's go ahead and tell me the question.
Why do they do that?
Because I mean, if you, it just makes you slow down. I mean, for those that are pretty solid on their code stuff, you know, it makes you not be able to just flip through the test too fast. I mean, if it was real simple and written pretty clear, then it'd be pretty easy to be prepped and be able to walk in the door without much experience and still be able to pass it. I think is their mindset, but I don't necessarily agree with that, but I think it's kind of what they do it that way. But Plus, if they put pressure on you in that manner, in other words, if they make you slow down and read your questions a lot more carefully than you would have normally, then that means you've got less time to spend on the math portion or the other portions that guys are usually weak on anyway. So it's just kind of a cheap way of slowing you down, I guess. Let me get my timestamp.
It's like my sound is dipping out for some reason.
Can you hear me okay? Is it my end or is it yours?
I got that text message a while ago and it's been sounding funny since, so it's probably my phone.
Okay, all right. I don't have it in this other book I pulled up. I don't guess because I don't see it, so I'm gonna keep looking for it. But you get my point on that, I guess. So that's enough to beat me with the dead horse. And then I think he told me. Let me get my notes out from that conversation I had with him. I had a long talk to him after he passed. There were not any conduit fill at all, and he could remember if there were. He just didn't recognize them. And that's about right on the conduit fill. If there's a conduit fill question listed, it's going to be a trick question, or it's going to be one that you wouldn't immediately necessarily recognize as being something not standard. But if you have one, be careful. It's not a standard question by any means. Let's see. This is my notes from yesterday. He had a question that he said he looked for forever, and we even talked about it in class. And I talked about it in just about everybody's class, but it was the question is asking you about a non-elliptical cable, and they were asking you what the measurement was used for conduit fill purposes. Is it the
widest part, right?
Yeah, but it's the way they worded it was the smallest, the biggest, the major, and then there's something else on there. Let me get my notes. I think they're in another room. I'll be right back. Give me 1 second. Well, I took them with me yesterday, or the day before, to make some notes. I guess when I was waiting. Oh, there they are. There they are. Right there behind me. But that's good that I went to go find these because I found some other ones that were important too. So, okay. Can you hear me? Okay. Can you hear me?
Yeah.
Okay. There was a
Yes.
question that, okay, so there was no voltage drop that he saw or recognized that he thought, and that's probably about right. No box fill. That question about the major diameter, they were giving him, is the minimum, the maximum, the total, or the major is the option to pick from. And it's the note 9 in chapter 9 on page 756. Yep, that's it.
Okay.
Second part of that. So it's the major, the lips. Major diameter is what's used, of the lips is what's used to calculate that. He said that he got about 80% of that review section that I was telling you about. He got about 80% of it reviewed that morning, and he said most of those questions were on his test, so he didn't really give me a percentage. I told you earlier it was half, but he didn't give me he just said most questions were on his test. There was a question about arc fault protection and what the UL listing was, and I think we covered that in class, and I think it's in the book somewhere about being 1699.
Yeah.
Okay.
69.
There was some questions about showrooms, and we didn't do a whole lot of showroom stuff in class. So let me kind of give you a quick recap on show windows. I would probably tell you to make these notes on page 68, I think it is, under 220.14F. Where's the G?
220.14.
That's 68. It's 220.14G. There's actually a couple of notes that we need to probably make on this one anyway, just kind of cover them real quick. But the first note being that the show windows under G2 at the bottom, those are calculated under 200 VA per 1 foot of show window. But as those are continuous duty, now I don't see how they couldn't be classified as continuous duty being in the store, it's a retail store or something like that. So it's going to be actually 250 VA per linear foot instead of 200 VA per foot. Does that make sense? Because 200 volt amps times 125% for continuous duty would be 250 volt amps. So just a note that it'd be actually 250 volt amps per foot because of continuous duty. The other thing is the receptacle requirements. There's two code sections that require the receptacles on the show window. The first one says that it has to be within 18 inches of the window sill. So a receptacle that's for show window has to be within 18 inches of the sill. And then the other rule says that they have to be one every 12 feet, every 12 linear feet. And so if you've got those three notes down there next to G2, I think it would be pretty good with that. So it's one receptacle every 12 feet.
Okay.
And then it's 250 volt amps because it continues duty. And then those receptacles have to be within 18 inches of the window sill.
Okay. Got it.
Then the sign and outline lighting is a branch circuit of continuous duty, but as a service calculation, it's not continuous duty. So that 1200 VA that you see under note F, it tells you that you have to have that 1200 VA allocated for the service calculations for every one required in 600.5A, which is basically every tenant space. You've got to have a sign circuit that's dedicated for it. And over there, it's a 20 amp minimum requirement and a 1200 VA on the service calculation just to be added there. And then heavy duty lamp holders under E. I think in class we went through a couple of different sections and you wrote some page numbers down there. Is that right?
That's for the lamp holders, yeah, 210.21 and 410.62.
You got 210.21 and 410. And there's one more. It wouldn't hurt to put 422.11C down there, even though it has to do with infrared lamps. Infrared lamps and heavy duty lamp holders have a lot of sections that are conjoined, and that's a 50 amp max rating on infrared heating lamps.
Okay.
422.11c, and you'll see that question in a couple different manners sometimes. But receptacle calculation was another thing that he had, and he had one question that I thought was just a journeyman test question, but it was in line with the type of calculation stuff that had been given lately on the master's test as well. And it's all about calculating a bunch of receptacles in an office building, but you have to be real careful the way you count them, because in the question they give you they give you 50 receptacles in a general area, and then they give you 4 receptacles in each of the 10 office spaces. So that's another 40 on top of the 50. So you get 90 receptacles just off the bat, and then there's 4 receptacles in each of the 4 restrooms, which is another 16. And I think he missed the 4. I think he just counted 4 instead of 16, because he just said there's 4 receptacles in the 4 bathrooms, not trying to multiply them out. And then I think the break room has got 4 additional receptacles. So it's 50, it's 40, 16, and 4. What does it come out to, 120?
Oh, man.
It's let me see here. Let me pop this up real quick. So just write this out in a second.
Good. 16, 40, 50. Yeah, 120.
Yeah, let me grab a quick piece of paper, and then I'll share it with you.
Your sound's cutting down.
Some of it's me talking a little too low. I'm kind of mumbling or uttering some to myself here. Let's see here. Why are you the active speaker? Okay. It is a. Let's share screen here. All right. So you should be able to see my little drawing pad here. Is that right?
Yes.
So if I had a list of questions, I don't know if I can do text or not. All right. So if I had 50 receptacles, which is the bulk that they give you in the beginning, and then they give you on top of that 4 receptacles, and they give you some details about these outlets. So they're telling you that they're like 20 amps or 15 amps or UCIs or whatever, but it doesn't really matter to you, because it's all about the yoke or basically the gain that device takes in the box. So if I've got a simplex or duplex or quad, I'm going to count each one of the gains that a device fills up in a box as 180 volt amps. Okay. And this is for non-residential. This doesn't apply to residential in any way, shape, form, or fashion, but commercial offices, retail spaces, anything like that, restaurants. So 50 is all that I care about. I don't really care about the amperage rating. Plus there's 4 in each of the 10 offices that they give you. And so 4 men in each of the 10 offices give you an additional 40. That gives us 90 so far. And then there's 4 in each of the 4 restrooms, which is another 16. And then we've got 4 in a break room. And so ultimately you're looking at 50 plus 40 plus 16 plus 4 gives you 120, I think, right? 90, 106, 110 actually. 50 plus 40 plus 16.
40, 16, yeah, 120.
110. I got 110. So 110, I'm going to multiply each one of those gains times 180 volt amps. It gives me 19,800 then as a total calculated load. And that will be one of the answers to pick from. probably be the first answer on the answer block, to be honest. So 19,800 being the first choice, and that's what we consider to be the connected load. So that's the full code amount of 180 VA, no derating, no considerations taken. It's just 19,800 across the block there. So normally, in any other kind of building other than an office or a bank, those are the two places that you have to be careful of. And if you look under page 69 on section K, which is the left-hand column, kind of toward the middle. Section K is a special rule for banks and office buildings because we know that the receptacle loads under those two types of occupancies are going to be heavier in use because of all the the devices and stuff they have, or the things they have plugged into the devices like copy machines and computers and stuff. That's a heavier than normal load on the general receptacle outlet circuits. So they mandate us to have at least the stuff that's prescribed or calculated under section I, which is what we're doing right here with this 180 VA for each receptacle. So that 180 VA comes out of section I, which is right above the on the same column there. And then we have to take. Go ahead.
Oh no, I got it. So we do, and that's the part of the public lighting thing, right? Where it's 125%.
No, general purpose receptacle outlets would never be continuous duty considered because just by the nature of the fact that we don't really know what's going to be plugged into them, so we can't really call it continuous duty. So that there'll always just be the 19.8 is as high up as it would go. There's not any increase on it. In fact, we are normally permitted to decrease that number. So if you look one page over on the top of page 70, on the right-hand column under 220.44, there's actually a D-rate table for commercial receptacles.
Oh yeah, the everything over 100 kVA.
Yeah, so we take the first 10,000 of it we can take at 100%, and then after that, anything that's above that amount we can D-rate. So normally, even in an office building or a bank, I'm still going to take that D-rate under. If you look at the way K1, so flip back to K1 real quick. K1 tells you that in banks, office buildings is calculated to be the larger of either 1 or 2. Well, section 1 is exactly what we just did on the screen there. It's taking 180 volt amps, and then under section I, I'm permitted to take the D-rate of. In this case, I would take first 10,000 at 19,800 out, and that would leave me with 9,800 as a balance, and that's the amount that I can take that 50% D-rate against. So I'm going to take 9,800 and divide that by 50% divided by 2. So 9,800 divided by 2.
49.
What is it?
49.
4,900. Gives you the 4,900 is added back to the 10,000, gives you 14,900 as a D-rated value. However, K2 then says what the larger of those two is going to be either that number, which we just calculated and then D-rated, or if the square footage value of that office or a bank is larger than this number after it's been D-rated, we have to take the square footage under that consideration. The problem with that test question in particular that I'm talking about in this case is they don't give you the square footage. So I'm not going to take the D-rated off because I just don't know where to draw the line or where the threshold might be under K2. I'm just going to simply take that 19.8 and be done with it.
Yeah.
Now, there's other questions that do similar stuff where there's a bank that's got 15,000 square feet, and the bank question's got 15,000 square feet has, I think, 120 receptacles, and they give you, and we worked this one out in class. Do you remember it?
I don't remember it, but I probably have it written down somewhere.
Okay, well, if I had a bank that had 15,000 square feet, and this is a bank with the same rule as office space is, so square feet.
Yeah.
And I've got 120 receptacles. My answer blocks are going to be 18,000, 360 is the first answer they give you. Sorry about that, I'm running out of space here. 18,360. Now I need a tablet or something. This is getting ridiculous. I can barely help manage my mouse normally. What am I supposed to do this like this? So it's 18,360.
My tablet's
Huh?
Because I don't know how to use. I have to use mine as a calculator.
I've got a tablet and I can log in there and use it, but the problem is I gave it to my wife so she got her login stuff in it. And I don't know how to get to I don't know how to download something without her password. So Yeah, it's crazy. It's always looking at notes anyway. Wait, it's downloading. What it asked me for or anything. Is it? How do you like that? No, it's not asking me for a password after all. Let's see if that logs in or pulls up. Anyway, so 15,000 square feet. I'm looking at 18,360 as the first block answer. And work that out.
Uh-huh.
What's 15,000 times? Excuse me. What's 120 times 180 come out to be?
I just did it. 21.6.
21.6. So it's not that much then. What it is going to be, it's 18,360 divided by 180 is, it's 102 receptacles, excuse me. So they give you 102 receptacles in 15,000 square feet. That's what's given in the question. So 102 receptacles times 180 VA is going to equal 18,360.
Yep.
All right, so that's the very first answer to choose from. And then they turn around and give you 14,180, and then they give you 15,000 as the third answer. And then they give you, huh?
I lost you there for a second.
Okay, so they give you the 18,360 as the first answer to pick from, and then they give you 14,180 as the second answer. And so the 18,360 is the answer is if you just did it straight across the board without any derates.
Yep.
And then so similar to this one down here, but then the 14,180 would be as if you did take the calculated derate for the receptacle loads. And then finally the third option is if you're looking at K2, you know what the square footage is. So the problem that you got with this one versus the last one we didn't know what the square footage was, so we couldn't really derate at all. This one we would want to derate under K1 because that's what we do under note I, which would give us this answer right here, which is the 14,180. But the fact that we have this square footage then means that that's going to be the bigger or larger of the two calculations under note K2. All right, so just you got that. If they don't give you square footage, you probably don't want to derate in a bank or office building. If they do give you square footage, it's probably relevant. You need to pay attention to it. And then multi-outlet assemblies, we didn't really get a chance to do those in class, or did we do one of them?
I think we did one of them right as we were leaving on Saturday night.
Okay, that's on the top of the left-hand column on page 69. It has to do with non-simultaneous types and simultaneous types. And if we have time to come back later and do one, I'll be glad to, but we've got a little bit of stuff to cover. So this section 1 is going to be every 5-foot section plus any fraction is going to be counted as one count. So if you end up with a 6-foot section, that's actually going to be 2 counts because it's the 5-foot piece plus the 1-foot counts as a whole 5 feet section. And you don't want to add those up first. You want to do them individually, each piece, and then convert them to counts and then multiply times 180 VA. This is one of those things that section 1 and section 2, section 2 being the simultaneous or over 1-foot counts, or any fraction thereof, they're calculated under 2 different methods, so you can't really add them together until any demand loads have been applied to each separate section separately. So if you hit under a section 2 where you've got a bunch of links that are all in the same area or the same continuous room or whatever that are considered to be simultaneous in use, not continuous duty use, but simultaneous use. Those are going to be probably, I've never seen a question where they didn't reach enough to hit you over this 10K mark, that's the table on the next page of text. So you're going to want to derate anything that hits 10K or above, but it has to meet 10K in its own section. So in other words, you don't want to put section 1 on top of section 2 and then take the derates under the table on the next page. Section 1 has to make 10,000 all by itself before you can derate it.
Okay, yeah, so I had to do each one separate.
Yeah, and then whenever it's all said and done, after you're done derating number 2, and then there's not much to derate because you're kind of derating the number 1 just by doing that 5-foot to 1 count, watering down ratio anyway. If that makes sense. So, but again, none of that stuff is continuous duty. I've never seen a receptacle calculation on the test have anything to do with 125%. So please don't. Common mistake, but it's the fact that we're dealing with stuff that's kind of non-general or non-specific. It's kind of general in nature. gives you the pass on having to worry about that continuous duty. So, all right. And then finally, I would put a note next to section I on page 69 that marina receptacles or outlets for marina shore power for boats or marina locations. Those are calculated the same way, but there's a table specifically just for them under 555.12. And so just a quick note to yourself there. And then the page would be, let's see here, the page number right down next to it. Page 538. And I just put next to the note I there in the margins. Marina.
Okay. Yeah.
And then so the D rate's just based on the number of receptacles you have there. It's just one number against the whole mass, but it's still going to be 180 VA per yoke, so you still have the same calculation there. 180 VA each, and the D rate conductor. 555.12. Page 530. I'm writing some notes down in somebody's book for them in case you want to know what I'm doing here. So I think that's pretty much it for receptacle count. Oh, there is one more for you. If you look at the wording of note I, it's split into two sections, but they're two separate sections again, so you don't want to do them the same way every time. So if you have 4 receptacles that are located on the same piece of unit equipment, in other words, if I've got a crash cart or I've got some piece of manufactured equipment that's got receptacles on it as part of its equipment there. If I've got 4 receptacles on there, then I change my counting from a 180 per yoke to a value that is considered just 90 per receptacle instead of 180 per yoke. So a single simplex receptacle would then count as 90 instead of 180 because it goes by the receptacle, not the yoke at that point. But on the wall, sitting on a wall, anywhere, any kind of a building, doesn't matter what kind of building, as long as it's not residential. If it's in a wall, then it's 180 VA per yoke. So a simplex would be 180 VA, a duplex would be 180 VA, and a quad would be 360, 180 for each gang. But
Okay.
if they give you a question where you've got 3 single receptacles, which is what they're giving you on this question if you have it, and they give you 4 duplex receptacles, and they give you 2 quads, and they kind of give you wording that tells you that those are actually 2 duplexes. There's 4 receptacles in that quad. The only thing that you would change differently is that those 3 singles in the beginning would just be 90 each instead of 180.
Okay.
Still count the same because 90 per receptacle and duplex still gives 180 for 2 of them anyway, so still kind of the same deal. And I think that's good. Dwelling occupancy receptacle calculations, there are none, except for the required ones that we have under 220.52 A and B, the small appliance and the laundry. So there's never any way you'd have any way to calculate a receptacle load on a service for residential dwelling ever, period. That would be more than 4,500 volt amps or 3,000 volt amps if they take the laundry room out or whatever. So it's been a while since I've seen those questions on the master, so I think it's good with just knowing that. Showing the track lighting, you have kind of the same thing on the bottom right hand corner of page 69. I think that takes care of those general notes. All right. What led me to give you all this dump of knowledge? What were we talking about? Oh, the signs and the show windows, right? Huh?
The sound's cutting out.
Sorry. So I gave you all that to kind of get to the point where now we're trying to remember what led us to this to begin with.
Oh, we were talking about show windows.
Yeah, but what brought that up? So I'm wondering. I don't remember what was there a list we were going down? Oh yeah, I was on the list. I went to go get, and then it was right there behind me. Sorry. All right. So back to his list. So he had showroom questions there, and we covered all those. Then he had a 10,000 square foot office space. He had a 9,800 square foot office space that had receptacles listed there, but you couldn't remember exactly how many there were. But that was the one. You know what? They did give him a square footage on that thing. It was 50, 15 amps, and then 20, 15 amps, and so on and so forth. So there was kind of a breakdown. he's saying he had 9,800 square feet. So in that case, if that's given that way, then I would have taken the 14,180 as the answer. If that's the math on
Okay.
it. There was one 50 horsepower motor that was intermittent duty, and they were asking for the minimum size branch circuit conductor for it. If you had a nameplate of 50 amps on a 50 horsepower 480 volt three-phase motor that's classified as intermittent duty and had a 15-minute maximum cycle time on time, what would be the minimum size branch circuit conductor applicable for that motor?
Okay. 50 horse, 480 volt.
Nameplate's 50 amps to duty. My question is, do you use nameplate or do you use tables for size and branch circuit conductor?
I got it written down. It's you do is the nameplate for the circuit, right?
Well, I tell you, you size it based on how you think you size it, and then I'll work it out and see how close we'll work. I'm interested to see kind of how you come out on this one. So it's an intermittent duty. It's 50 horsepower. They've given you 50 amps as a nameplate. It's 480 volt three phase, and they're asking you the size of wire for it. So what size wire would you put on that motor? Branch circuit wire, not bigger.
Number 4 if it was real life. But
Excuse me 1 second while you're doing that. I'm going to be right back. I'm just going to use the restroom real fast.
are you there? I can't hear you at all.
I'm here. I was trying to do a quick note before I went, but nameplate is 50 amps is what they're giving you.
Oh, it's 50 amps. I just went ahead and looked up 50 horsepower and did it that way. But
What size did you come up with then?
6.
Number 6? All right, so how strong did you feel about your motor stuff? Do you feel pretty good about it?
Yeah, I'm pretty good. That's what I do every day, so
Okay.
I know why I pick the wire and stuff I do. I know most of it. I could, if not, I know it by experience. If they give me the stuff, I just know it off experience.
Yeah, I mean, a lot of times, like most of the motors I did back before I got into this side of the business was, I had a whole stack of those little slider things that you get from Square D and Cutler Hammer and
Truck too.
yeah. So I mean, I just you get three phase motor. So you slide and it gives you the wire size. There you go, ugly guy. Here's the deal though. The funny thing about motors, and I didn't really understand it as well as I did until I got into the theoretical side of it, I guess, the teaching side of it. The nameplate's a hard thing to ignore. It really is, because I mean, you pull a motor out of a box or out of a crate, it's got a great big, and you can't miss it, it's staring you right in the face. And when it's an air conditioner equipment, we're required by code to take that manufacturer's maximum, MOP on like an HVAC or pneumatic refrigerant motor as gospel. So even if your code calculation is higher or whatever it might be, you still have to follow the manufacturer's ratings. But in motors, regular old run-of-the-mill squirrel cage motors you put in all the time, just your capacitor start, I mean, just a general everyday motor. Those are code required, calculations based on the table values in the back almost every time. And so, what you did was going back there to pick that 50 horsepower, 480 volt, the FLC number out. That's normally what you should do. In the nameplate doesn't come into effect, except for, really the heaters, and that's about it. But this is that one weird spot that we've got a specific table for, motor wiring that's on the branch circuit side where you have a non-continuous duty motor.
The nameplate's only for the overcurrent station.
Yeah, except for a motor that's non-continuous duty. And so if you look under 430.22E on page 329.
430.32.
E. 22. 22 is your regular, continuous duty motors. And then on the right-hand side of page 329, you'll see the table, which is labeled E.
Yeah.
Look at the heading of that table.
5 minute 15.
No, that's the top, the label of it. I think it says
nameplate.
Yeah, it says nameplate rating calculator, nameplate rating.
Yeah, nameplate current rating percentages.
There you go. So that table is a real special table, but it fits this type of question where you got a motor that's specifically non-continuous because they give you intermittent duty, they give you a 50-minute cycle. So that 85% that you're looking there on the table is used in lieu of 125% against the table value. You'd use the nameplate at 85% instead of the other way around.
Okay.
And the motor's just not going to get very, those wires will never get hot. With 15 minutes on, probably like car lifts that have the motors that just kind of lift your car up in like a Firestone or whatever. I've had a couple of those jobs, and those are, they're on for maybe 3 minutes at the most, and that's if you're pulling up and down and got the kids playing on it or something maybe. But the heat on the conductor never reaches the problem like they do with continuous duty motors. So they even let us kind of, in some cases, make it smaller, but than 100%. But 85% then we've multiplied against that nameplate rating. So you got to draw a line either in the sand on that page or in your mind if you're dealing with a branch circuit wire. And this is the only place it matters. If you put that sucker in as the biggest motor in a group of motors the size of feeder for it, then it's a continuous duty motor. And what you just did would be correct as the first step. But when it's just the branch circuit wire where you got nothing else, you just take just the nameplate rate.
The nameplate value.
So 50 times 85% then comes out to be. And I think probably they may have given him, I'm not saying that the 50 horsepower or the 50 amps is right. It's probably closer to like 60 amps is what they probably might have given you, because 50 amps on a 65 amp FLC table value is probably pretty small.
Stan, it's a math problem, and not. You shouldn't be able to. It would be number 8 if you did it that way.
Yeah.
It'd be 2.5 amp, and then 75-degree table. Get the 50 amp wire.
Now you gave me an answer of the number 6. Is that right?
Yeah.
So had that not been, let's just say that question was just a regular motor that was not listed as an intermittent duty. Even if they gave me a nameplate rating, in that case, I'm going to ignore that and go back to the table value, and I'd pull it 65 amps, I think is what it was.
Yes.
But I can't put that on the number 6 anyway, because I'm looking at 65 amps as a starting point. Then I have to take 125% against that number, according to 430.22, which is on the left-hand side of the page. And so motors that are continuous duty, or it's pretty much everything that you're going to see on a test, unless it's listed otherwise. But under single motors, it's 125% of the full load current or FLC value. You take 65 times 1.25, and that would probably put down number 4, I'm guessing.
Yeah.
80, yeah, so we're good for 85 amps on number 4, and that's 81 quarter there. So that's really, I guess, my point on that. So as long as you kind of keep that straight. And then the other thing about motors is that's different than your field experience is the breakers and stuff. You're going to want to round those down instead of up like you normally do. So it's kind of a habit. I just kind of rounding them down.
Okay.
There's a strange question he had about some underground. There's an underground feeder, underground circuit that was feeding in underground in a round tube wiring method. I don't know if he told me it was PVC or if he told me it was rigid or if he couldn't remember, but he was specific on the fact that they did call it a round tubing, circular tubing. And it was stubbing up into a utility room, into a time clock, and asking you what kind of install is that, or what does it need to be done as far as the installation is concerned. What do you think about that question?
Oh, that was real general.
It was, wasn't it? It was one of those things that it's pretty vague. Even now when I'm rereading it, it's still pretty vague.
PVC stubbed up through the concrete to a time clock.
Yeah, and I wouldn't worry about the PVC part. It might have been rigid, might have been PVC, or might have just not said one way or the other. Might have just said a round tubing or round. He said round tubing is what he told me, so it sounds like PVC to me. But it's technically a rigid conduit, not a tubing type. So let me see. So it's stubbing up into a utility room into a time clock, and they're asking you what kind of install is that, or what do you need to do with that installation to make it code compliant.
I don't understand. What were the choices for the answer?
The choices were to be changed over to a different type. Uh, I think grounding bushing or grounding lock nut was one of them. Some sort of a seal or plug was another one, and the fourth one was I don't remember. I don't know what the fourth one was. I don't really remember it either. I think it's really a 33% chance out of those three. So you're stubbing up. You're stubbing up from outside the building to inside the building with a circular raceway. What's the rule on that? That kind of deal.
Oh, it's got to change over to steel. It can't. Well, it'd be plastic through the rock.
This is something I don't know that I've ever done this, so I'm not going to tell you that it's something you got to know by the back of your hand. But if you look on page 147 of your code book under 300.7 A, I've got it highlighted, so I'm aware that it's been around, but I've never seen it worded this way before. So it's something that is worth kind of mentioning to you. But if I'm bringing it from outside the building, inside the building, the rule is it's got to be sealed or plugged. So you got to have some.
Okay. Yeah, well, I know what it's talking about. It's like coming out of like a walk-in cooler or something like that.
Yeah, but
Yep.
this is even higher, further than that. This is even if you come from outside the building to inside the building, you got to seal them off now. And I don't remember. I don't know when that came to be because I don't remember ever doing that myself. But except for like a walk-in cooler, like you're talking about. But if
I
you
just inspection today for it.
do it,
I just passed an inspection today.
yeah, yeah, and even your like if you got any empties and stuff, it's supposed to be filled. But it is under portions of raceway sleeve known to be subject to different temperatures or when condensation or were passing from the interior to the exterior of the building. Raceway sleeves should be filled with proof or the explosion proof seals are not required. I don't know that anybody ever applies it because I've never applied that to outside to inside, but I somewhere there's another section in the code book that kind of supports that. And I want to say it's 225 or 230 somewhere, but I don't want to go digging for it just on a whim. But at any rate, that's the answer is going to be sealed or plugged. Is what you're getting at. So best I can tell.
Okay.
All right, so that's that one. There was a generator that they were telling you in a test question. There's a generator that was providing emergency power for this building, and I might have mentioned this in class, but they were telling me that it was out of sight of the point where the conductors serve or pass underneath that building. And they're asking, what do you have to have located on that building where those conductors go inside? You have to have a directory that points out to where the disconnect that's located at the generator is. You have to have a disconnect listing, safety points, or some other kind of alternate disconnecting means. And there was a disconnect as an option, and then there was a sign or something else, or maybe the sign was the placard or something, but or no additional disconnect means is required was one of the options. So disconnect means required, no disconnect means required, which the test question tells you that you've got a disconnect means located at that generator in the ATS transfer switch. So they're asking you, you have to have an extra one basically where it goes into the building and then it's going to land in an ATS or cabinet or disconnected means on the inside of the building too. So do you have to have another one there at the building where on the outside?
Does that have to do with the access, the qualified people, and?
No, but you know what? That's a good thought that you had. I'm proud that you even connected those dots. But it has to do with the fact that it's an emergency generator where you'll find it under 700.12 5 or 6. So really, the key there is that it's an emergency or a generator being used for the purposes of emergency support, backup purposes. And it's under 700.12 B6. If it's located within inside of the building, then you don't have to have a different disconnect means. But in this case, being outside of the building, you have to have one.
B6. B6. Okay, outdoor generator sets.
All right. He said he had a bunch of transformer questions on his test, and we didn't cover those in class very much. But I'm going to need to take a quick break just for a minute and come back and do those kind of. What time do you have? What time do you need to go?
What time do I need to go?
Yeah. You got anything pressing?
I'm fine. My test is tomorrow.
Yeah, I know. Oh, we got a fireworks display where the kids are going to want to go to. It's probably about 6 or so. So I'm going to have to shut it down for about probably 30 minutes or so. But I just let me give you 2 questions. Then you can write them down real quick, and then actually 3. And you write them down real quick, and then that'll give me something to go take. I just got to go grab something to eat and drink real fast.
Okay, what you got?
I've got a fire pump motor that is a 50 horsepower, 480 volt, 3-phase motor used as a fire pump. And they're asking what size breaker would you select, inverse time circuit breaker would you use to select to protect that fire pump. And the choices are going to be 500, 600, 400, and 800. So it's a 50 horsepower, 480 volt, 3-phase fire pump. Looking for an inverse time circuit breaker, an ITCB. Would it be a 500 amp, 600 amp, 400 amp, or 800 amp breaker?
Okay.
Next one is if I have 2 resistors in parallel on a 240 volt circuit, and they are, and I don't know if they were both the same value or if they were different. They didn't give me that part, but it's a 240 volt circuit with 2 parallel resistors, and I'll just give you a 12 and a 9 as an example, but I don't know for a fact that's what the 2 resistors were. But they're asking what's the ampacity on that branch circuit.
Okay, did you say 120 volt?
240 volt with a 12 and a 9 ohm resistor in parallel. What's the ampacity on that branch circuit? And then the third one's going to be 5 ranges that are in a residential building. They give you a 3,500 watt, an 8,000 watt, a 6,000 watt. So there's those 3. And then they give you a pair that are a cooktop at 3,500 and a wall mount at 6,000. What's the demand on the service? So 3.5, 8, 6, 3.5, and 6. 5 ranges. What's the demand on the service?
Was the house?
Residential, yeah.
Okay.
And I'll be right back after you. It was a pair of 6,000s, one of them being a wall mount, a pair of 3,500s, one of them being a cooktop, and then a 6,000, excuse me, an 8,000.
Okay. They were all cooked up.
Well, they're all ranges. 3,500, an 8,000, a 6,000. So they give you those three with no other details. They're just household ranges in the same residential building or occupancy. And then there's a pair that are a cooktop and a wall mount that are an additional 35 and a 6,000 for that pair. So it's a 3.5, an 8, a 6, a 3.5 cooktop, and a 6.0 wall mount. I'm asking for the demand on the service for those ranges. All right. So what did you get on the first question, which was the fire pump?
I came up with the 400 amp because I went with the locked rotor current and the next highest breaker on the fire pump.
Okay.
Is that right? That's what I thought it would be.
The inverse time circuit breaker multiplier that's on page 335, do you think you would use that in the calculation or no?
No, because the fire pump has to be able to carry the full locked rotor current indefinitely.
Mm-hmm.
So I would just go to the next higher, right?
Well, let me ask you this. An indefinite time period is probably longer than 3 hours. What about continuous duty?
I didn't think about that.
And if I thought of it at 400 amps, my locked rotor current on that thing is 363 amps, right?
Yeah, 663 or 363.
Yeah. So 400 amps cutting it pretty close.
So you'd have to do the 125 on the fire pump for the locked rotor current.
No, I'm using that as clarification to tell you that the 400 amp is just no possible way that would be meet the rule there, because I don't think it would hold past 4 or 5 hours for sure. But the number that we use for sizing a breaker, I mean by code, is under the table on page 335, the 430.52.
Okay. And see, that's where I get mixed up at is the little rules to refer back to this.
Right. Yeah, I'm with you. And it takes a long time to get them all down like I've got them. It's like you can't expect to get all of them at one time, but a couple of them here or there. But this is one though that's not real clear in the code book on really how to go about doing what the code intent is. And the intent is that you want that fire pump to all but set fire itself before it shuts off. So you can't just have it without any protection. But the only calculation that I'm aware of for inverse time circuit breaker would be under the table there at 250% minimal. And it's possible you could argue that it might even be a 300% value, but either way, whichever one you use is going to give you the same breaker size. So if I took that 363 and I sized the breaker based on locked rotor current instead of the FLC value at 250%, that gives you like 900 and something. Is that right?
I believe so.
And then there's a rule that we have under 240.6. No, it's earlier than that. It's 240.4B and C. It's 240.4B. Anything that's 800 amps or less on a breaker, generally speaking, unless there's some article that says specifically we can't do that, otherwise, we're going to round that up to the next standard size breaker. You go past 800, then the rule reverses under section C there and tells you anything over 800 amps, 801 above, is going to round down. Well, they only make an 800 amp breaker and they only make 1,000 amps. So any number that falls between 8 and 1,000 is going to automatically round that back down to an 8.
Okay.
So
actually, an issue with that. These concrete plants are like 890 amps is what they're rated at, and they're all on 800 amp breakers.
On the fire pump?
No, for these concrete plant, where I'm downsizing the breaker, because these concrete plants we work on and everything else, they're like 890 amps is what the full load, what they're rated at.
Yeah.
What the current is. And we put them all on 800 amp breakers, but we were having issues with the manufacturer saying that they needed to be bigger breakers, even though the code says we have to put them under 800s.
Yeah.
We went through that smaller breaker, that code reference.
Did the manufacturers ultimately win out? I mean, I would think they would, but I mean, there's nothing in Article 430 that allows you to technically do that. I mean, but they do have that wording in 440.
Yeah.
So, I mean, motors of other ilk do follow the manufacturer's recommendations, but are you having trouble with them tripping or blowing the starters out?
They were having trouble. It was only when it was really hot in the summer during the day when all the belts loaded and everything else. It was in the main.
It was tripping the mains?
What?
It was tripping the mains and not the overloads?
It was it was tripping the main breaker on the service. It wasn't even tripping the secondary breakers like the 400s that were going to the control panels. It wasn't tripping those. It was tripping that 800 for some reason. But it's not doing it anymore. It's going since last summer.
You're allowed to use exception number 2 in a case like that. So you'd be using, depending on what kind, if it's just a standard inverse time circuit breaker, you'd be using 400% for the smaller motors and 300% for anything rated for 100 amps or less. So I mean, you could tack on 300%, and then of course you have to round them down at that point. But it's hard. You get past 800 amps, you got 200 amps to cover before you can get to the 1,000 amp breaker. I mean,
no, they got the adjustments on most of them where you can crank them up,
but you're not making that 200 amps, are you?
What?
You're not picking up 200 amps on it, are you?
No, but you can adjust the interrupter rating, which is what it makes them trip less with the knob on the side. I forget what
that's an adjustable trip mechanism, but it's not the interrupting rating. I didn't think. I think that's just the trip setting on it. I mean, I don't know what the fluctuations are from brand to brand, but some of your bigger frame breakers, I know some of the Eaton Cutler Hammer stuff got mechanisms you can pull out and replace them depending on what
the little modules that come in them. Square D's got the ones that we have. I haven't seen any of them until we did these 3 plants, but I can't remember what the hell is on the knob. There's a red knob on them, and every one of them that we've had problems with them tripping, we just go turn up the knob.
So crank it up a little bit.
It works better. So.
Well, see, here's the thing: is that when you're talking about using a breaker in the first place, I mean, the heaters are designed to kick out. The problem you're describing is really a heat issue. And it just compounded when the heat of the day, the ambient temperature rises, and the normal temperature operating conditions are already high anyway on a motor, so you tack a higher 100-degree ambient temperature on top of that, and then run them all day long, and it's too much. But it's the heater that should be tripping long before that breaker should be, because the breaker is just used as the interrupting capacity or the interrupting limit, which is what you were mentioning a minute ago. That's the high end part of the protection in a two-piece protection breaker like that. So
the issue with these guys are they have a certified electrician that works for them.
Certified, huh?
Yeah, he's certified electrician.
In a mental hospital or what?
I don't certified him, but it's cranking up every motor starter and everything else. If you go look at any of the motor starters, they're turned up all the way. If it's
he's losing his thermal protection and just leaving himself wide open for winding damage, and then he's just trying to use the breaker that protects. And that's typical. That's a guy that just. I mean, he's an electrician that knows a little bit about what he's doing, but he doesn't really know the real big picture behind all of it, I guess.
Yeah.
I'm just, of course, that was kind of quick for me to judge him like that. I guess it should have been quite so quick to say that. But
On the resistor one, it's parallel, so I add them together, and my voltage is the constant, so I would divide my
resistors don't add together in parallel.
Add together in parallel?
Yeah, only in series when they do that. And in parallel, it's going to be less than the smaller breakers. The sum will be. So I gave you a 12 and a 9. Is that right?
Yes.
So the easiest way to do parallel resistors to me, instead of having to do the because what you're looking for is the total amps, right? So in a calculation, you're looking at a VAR, the V being the top number, the A being the total and the resistors. So if I'm looking for total current, I have to know the total voltage, which they're giving me, and I need to know what the total resistance values are. But to get that total resistance value in parallel, I got to use an inverse reciprocal formula, or I can use a parallel resistor formula that's pretty easy when there's just two of them. It's the product over the sum formula, which is on the top of your formula page. It's right before the Ohm's law stuff, I think. Yeah, I think it's on that one as well. It would be no, it's not on that one. It's in your textbook. I think I'll pay like 53 or somewhere in that before the Ohm's law stuff.
Okay.
And it's got the little round circles, the voltage drop, two kids on the block, and circle in the middle in yellow, and then the black circle on the bottom. Little color table on it.
I think I have it. It was I tore up my book. These?
I can't see. Yeah, basically that on the page that you got most of that off of, there's an R1 times R2 divided by R1 plus R2 will give you RT. Now that in this case, since there's just two of them, it's probably faster to do that than it would be to do the one I'm fixing to tell you about. But I get in the habit of just doing the same thing every time, whether it's 3 or 4 or 2. But all I know is that a VAR formula is real simple if I'm doing it with instead of the branch totals. If I'm looking at it just as a point calculation, just at one leg of a branch. If I know that I've got 12 ohms resistance at one point, and I know that it's in parallel, I know the voltage is going to be the same anywhere I'm at. So I've got a 240 volt value both at the branch total, and I've also got it at point A and point B where I've got resistor A and resistor B. So if I just do a VAR calculation at 240 volts and divide it by 12, that's going to
get down and add them together. Okay.
Yeah. Find the amps at each load location. In other words, real simple, and then add the amps together, and that way you never have to worry about the resistor totals.
Okay, that's what I screwed up.
So 12 into 240 gives you 20. Right?
20 and 240 and 90 gives me.
Yeah, that one I can. 20 to 27.
I guess. Come on.
I was just guessing. I didn't do 240. Divided by 9 is 26.66. That's pretty close. I was only 0.33 off. But 20 is round up to 27. So it's 27 plus
20, 47
total amps.
Okay.
Now, if you did it as 12 plus 9.
Yeah, I added the ohms together before.
Yeah, if I do 12 times 9, which is 108, and divide it by 12 plus 9, which is 21, that'd give me 5.14 ohms. But then I'd still have to turn around and divide that into 240 volts, so I'm still doing more steps that way. 4 divided by 5.14, and I get 46.69, which is 47. So same answer, but it's just one less math problem to do. All right, so that brings us to the third one, which is the ranges.
Yeah, I hadn't done that one yet, but
okay. You understand the ranges pretty well?
What?
You understand the range table pretty well?
Yeah, as far as breaking them down and everything else, I understand that. It's just my problem is which one to use. Like I'm still having trouble separating like standard and optional.
Well, here let me get the standard and optional out of your head, because I think that's what's part of the confusion. Really, this table, the big issue on this table is this a service calculation or is it a branch circuit calculation?
Yeah.
I mean, because this table is the standard method. You can't use it for optional ever. So there'll never be a chance that you'll be calculating an optional method and use this table, period. So it's a standard table, and that's all it is. But it's a standard table that was designed for the service calculation. The wires outside the building on your service, that's what this is supposed to give you, is the additional amount that you just have to tack on for the wires outside the building. Problem is that note 4 kind of confuses the issue and says, all right, well, we'll allow you to use the same table that you use for the service calculation if and only if you stay on line 1. You can use it for calculation of branch circuit. And then they kind of even make it even worse, because in the second part of note 4, they tell you, oh, but by the way, you can still be on row 1 if you've got 3 units, as long as they're a cooktop and not more than 2 wall mounts and that kind of combination, I'm allowed to add them together artificially. So I pretend like I've just got one gigantic big range that's all on row 1. So, but you're still, either way you're looking at it, when I've got 5 ranges, I couldn't care a whit's ass with their cooktop or wall mount. There's no way I can use that table for anything but the service calculation method, because that's all that table is for. And if I get more than the 3, that they give you down there, and 4 is the maximum value, it's done deal. It's why I tell the class, and my stance on range questions or any question that involves a range, my first question always is in my mind: am I calculating out a service calculation, or am I calculating a branch search calculation? And once you get that in your mind, then it makes it a little easier to apply the table, I think. Because, in this case, it's a service calculation, because you can't, the rule of no 4 caps out at 3 anyway, so there's no way you can use it anyway. But you certainly couldn't extract that cooktop and wall mount down at the bottom and treat them separately and then do the 3 at the top separately and then try that, because it doesn't work that way either. So it's just going to be the second question in my mind, once I've determined it's a service calculation, is what column does each range in that question fall under? And all 5 of these are column B ranges. 3,500 is the start of column B, so I'm looking at 3.5 and 8 and 6. I'm going to add them all together. And I've got 5 ranges on column B, and I'm going to multiply them times whatever that number is, 43 or 45%, I think.
Yeah.
So it's a little bit more simple of a question than you realize, but they throw that cooktop and that wall mount in there just to try to throw you off your tracks there. But it just if they're not talking about a branch circuit conductor, then it's going to be on whatever row you end up on based on the number of units there are. There won't be any combination of units or anything like that. Hello there.
Okay.
So you're going to add up the 6,000. You add the 7,000 plus 12,000 plus 8. That's 27,000 total, right?
Yep.
How are you doing?
0.40.
What are you
12, 150.
making?
It comes out to what?
12, 150.
12.6?
12.1.
Yeah, 12.15, I think. So it ended up being 12.15 kVA is the answer.
Hey.
How are you? This is my oldest daughter, Hannah, and then I got a younger one named Savannah. Go get Savannah.
Okay.
Go get Savannah. No, wait.
Daddy?
We met the 2-year-old at the class,
Oh, that's right. You meant to do it.
or the 1-year-old.
1-year-old. I was going to say 2-year-old. I said that back to you like it was correct, but it's not. Go get her. Go get her.
Daddy?
Go get her, and I'll be done here in a minute, and then we'll go. Okay?
Go where?
We're gonna go to the park and then go to and see fireworks and stuff.
Oh, yeah.
Oh yeah.
A 1 and a 2-year-old.
You have a 1-year-old and a 2-year-old?
Yep.
Now you need your master's license, don't you?
Yeah, I
Doctors
do.
alone are killing you.
My wife can't work because it's too much for her. It's just too much. With
Oh yeah, we can't handle this 1-year-old. We're pregnant. We're gonna have our second one here in September.
yeah, good luck.
Yeah, I know. Yeah. Anyway, so there'll be a lot more of those interruptions, I'm sure. So that's that. Do you have any questions on any other ones that were in the book or anything else?
Let's see.
Oh, transformers.
Yes, Transformers.
Transformers, to make your life a little easier on transformer questions. I don't care if they're a delta, I don't care if they're a Y, I don't care what the actual winding connections are. I say that, I do in some cases. But the bottom line is that there's one key mathematical principle with transformers. And that is WAV calculation equals a WAV calculation. In other words, if I have a transformer, the 3 values on the primary, there'll be 3 values on the secondary, but that top value, the watt value, or the volt amps in this case, would be in the transformer, would be the same number.
Yeah.
Daddy?
So I can manipulate those. What happened?
Lucas thinks we don't need him.
Oh, should we go sleep or something?
No, he's not. She is awake.
Oh, but she thought that I didn't need him, that you were just going in there to get her yourself.
I told her.
It's okay, baby. We'll go in there in just a minute. It's okay, baby. You know. Here, here you go.
Don't try to my Lucas iPad.
Just a minute, I'm almost done using it. Here we go, baby. Hold on.
What? What's done?
Let me know.
Is there a note? What is saying?
All right, take that and show that to her, okay? That's your pass. All right, so if I have a breaker to size on it, the same formula is what I'm using, WAV. I'm sizing the breaker with the primary secondary protection, usually on the primary amperage value. And most of the time we protect the secondary through the primary protection anyway. But the split on transformers is under 450.3 A and B, is it? 450.3 A and B? This is the one place in the code book that the over 600 volts, in this case over 1,000 volts, comes first, and the under 600 volts or 600 volts and less comes second, which everywhere else in the code book is the other way around. But 450.3A is.
Yep. 362 and 361.
Thanks, sir. Page numbers always be the article reference any day. 362 and 361. 361 is for over 1,000 volts. Can I borrow half a second? That's all I was asking. Come here, Mama. You're so cute. We're almost wrapped up. Hey there. I love your ponytail. That's very, very patriotic. Happy July the 4th.
Nice.
How you like that? And that rounds us all out. Okay, so if it's rated over 1,000 volts, there's a transformer question that's kind of real difficult looking. It's rated over 1,000 volts, and they give you that it's in the supervised location. They give you this 2% impedance maximum value and a bunch of other details. Bottom line is the first thing you ask yourself on a transformer calculation is is it over 1,000 volts or less? And if it's over 1,000 volts, it's going to be the table on 361. And the only notes to really worry about, you'll notice that you have primary protection in the first the first two columns. And then you've got secondary protection split into over 1,000 and under 1,000, basically. And so if you had for example, an overrate 1,000 transformer with a primary rate over 1,000 volts, and you're trying to protect the secondary of it, which is rated at 480 volts, then you'd use the very last column on that page, depending on the location, and then what the impedance values are. And anything that doesn't say see note 1 on it, note 1 is the rule that allows you to round up on a breaker or a fuse for a transformer. And anything that doesn't say that then would be a round down step. And so almost everything on the bottom half there is going to be on that right hand column. Both of those supervised locations are going to be rounded down.
Okay.
The one I've seen, the one I was just talking about, falls under the middle row on the bottom 3 down there, where it says not more than 6% impedance. And and they're trying to protect the secondary on it, which is a 480 volt rated 3-phase secondary. Come over here, Anna. Come back over here, baby. Come over here.
You done?
Hannah, come over this side. Come over this side, please. No, that's fine. Hannah, over here, over here.
I'm going.
Oh, sorry. You're looking backwards over there. All right, so you'd have to do the math on it, though. They give you the fact that it's 200 kVA, and then it's rated at 40 volts on the secondary. So you have to do the secondary voltage, amperage calculation, which is 200,000 divided by 480 times 1.73, since it's a 3-phase transformer. And that gives you, I think, 200 and some odd amps, and then multiply that times 2.5, and that gives you 602. And you'd round that down to 600 amp breaker. Fuse, excuse me.
I believe you. You said it too fast, second time.
Now the second one, the table that's on page 362 is really easy. And if it's rated over 9 amps or more, so that's the first column there. And then it's split into 2 types, either primary only, which is typical, or primary and secondary protection, which is typical. Is the second row. Both of those are pretty easy to use. The top one you round down, the bottom one you round. Top one you round up, the bottom one you round down. So if I'm using 125%, I'm going to round that up to the next standard size breaker. And if I'm doing a primary and secondary protection, I'm going to be rounding down for the lack of 1 there being on the second, the bottom row.
Okay.
So it's really going to be just the math of a WAV calculation. The only thing to remember is that if it's a three-phase transformer, you want to use the voltage at a 1.73 increased value for it. So to get the amperage there and this does matter if it's a delta or Y, because on a Y went on secondary, which most of your business services and things of that nature, commercial services, are going to be a Y output. Might be a delta in the primary, but it might most likely be a Y. But the Y calculations are going to have the 1.73 applied to the line voltage, and if it's a delta, it'd be against the amperage, not the voltage. So, but I've never seen them give any kind of calculations that are that complicated on the transformer stuff. And then the rest of the transformer stuff, if you're looking for, like if you got a 240 volt transformer that steps down to 120 volts, it's still a WAV calculation. You can manipulate either side of that, just remembering that it's a inverse proportionate relationship between the amps and the volts on each side.
Yeah.
So if I go from 240 to 120, then I'm going to have, it's a half drop. I'm going to double that number going the other direction with the other value. So if you pencil it out as a WAV and just pencil the numbers in, you can figure them out just like that, and you don't have to remember anything else.
Yeah, most of the transformers, I can look at the amperage, you can look at the size of the amperage and figure out what size they are.
Yeah, I think so. The only other thing to be notated about is that above a drop ceiling, the largest transformer that's permitted in that case is going to be 50 kVA.
50 kVA.
And that's on page 365.
Right. What's the?
It's 450.13b.
Yeah. Okay.
And then on that same page, under the section 2 there, where it says 450.21b over 112.5 kVA, you have to have those in at least a transformer room, but a room is different than a vault. And the room under this section is fire resistance minimum rating of an hour. Transformer vaults, though, a little further back, are all going to be 3 hours minimum fire rating. Just about every component there, whether it's the floor, the wall, the ceilings, roof, it's all going to be 3 hour minimum rating on a vault.
Okay. Yeah, vaults are 3 hours.
Rooms are 1. Yeah. And then you've got a ventilation question that pops around every once in a while on the back of 368, or on page 368 on the top left-hand corner there. Is that real? You have my phone number?
Yes.
Can you do me a favor and text me? I couldn't find your. I know you texted me because I've seen your name on your text, but I need to send you that list of ones that were off that other guy's exam, and he did a pretty good job of listing them down. So if you'll send me a text real quick, I'll respond to that with that list, and then I'd spend the rest of my evening going over that middle group of those articles of study, and I just stay on that and nothing else. And then the list that I send you tonight, and if you have any questions on any of that, don't hesitate to call me and ask about it, because I'll be happy to I'll text back. I'll probably not be able to call, but I'll be able to text you.
That's fine. Yeah,
Okay.
That's cool. Cool,
well,
man.
I enjoy it. Listen, when
Right.
you get in there, don't let that time stuff go to your head. Just take your time and go through it and do it one by one, but don't get married to any one question.
No problem.
All right, man. Call me and let me know what happened.
Yeah, I'll call you tomorrow right after.
Okay, thanks, man.
All right,
Good luck.
thanks. Bye-bye.